Let's try to solve this problem here. It mentions that a projectile is launched from point O. So I believe this should be point O, and they didn't mention really clearly, so this should be point O at an angle of 32 degrees. So you can see that the initial velocity vector arrow is 32 degrees from the horizontal. Okay, so this is the angle. So it is thrown with an initial velocity u. So this is the initial velocity vector arrow, and this u here has a magnitude of 15 meters per second as shown in the figure above. Okay, when the projectile reaches point M, so the object, whatever it is, we call it projectile. So when this projectile reaches point M, reach this point over here, it is 2.62 meter from the ground. So this one is not labeled inside here. So there are many things not labeled inside here. Let me try to label it now. Okay, so it mentions here that you are moving with 15 meter per second initial velocity. So your initial velocity is 50 meter per second. As usual, I don't really label it as u if it's not written here, but since it's labeled clearly u, I might just as well write equals to 50 meter per second. Then it mentions here that this point here is 2.62 meter from the ground. Okay, so we have labeled everything. I believe we have completed step 1, which is to visualize the situation. Okay, so now let's move on to the sub-question. Sub-question A, find the time it takes to reach point M. So I believe the time it takes should be from the start or from the launching moment until it reaches point M. So this whole journey here, how long does it take? That's what they're asking for. Okay, so if they ask for the time, then we know that the initial position will be at the point where it launched, and the final position will be point M because that's where it reached, right? So let's move on to our step 2 by labeling our initial and final position. So our initial position will be somewhere here. So this is initial for question A. And for question A, the final will be over here at point M. So this is initial and final. We have labeled. So that's step 2 done. So now we move on to step 3. We write our SUVAT based on our initial and final position. Okay, it's based on this. It's not based on the situation. It's based on your initial and final. You determine your SUVAT. But again, since this is a projectile motion, it's a 2-dimensional motion. So if you have 2 dimensions, you have to split it into the x component and the y component. So this is how I would do it. So I'll write it for the x component. I'll have my sx, ux, vx, ax, and t. Okay, t I put in the middle because there's no tx and ty. T is a scalar value. There's no direction, so you cannot split into component. And both the x component and the y component share the same time because it's one object moving. It's not 2 objects moving. So they should be sharing the same time. So I put it in the middle. So this will be x. Of course, we also have another dimension, which is the dimension of y. So we have sy, uy, vy, ay. And this will be equal. So we are going to fill in the blanks, what we know, what we don't know, and what we want to determine. So the distance from sx means by it's from here to here. Do we know this distance over here from initial to final? What's the horizontal distance? We do know. Okay, it's not mentioned here, so we leave it blank. The initial x component velocity, well, I believe you can determine it. We know that this is the initial velocity and it's pointing at this angle 32 degrees. So if we resolve it, we are able to get the x component, which is this side, and we are able to get our y component, which is this side. Y component, we'll do it later, but for now, x component, this is our angle, so this is opposite, this is adjacent. So adjacent, use cos. Okay, so it's 15 cos 32 degrees. Again, double check the sign, whether it's pointing to the right or pointing to the left. In this case, it's pointing to the right, so you make sure it's a positive sign in front. If it's pointing to the left, you have to remember to add a negative. Okay, it's sign sensitive here. Anything pointing to the left or pointing upwards, you put positive. Anything pointing to the left, anything pointing to the right and upwards, positive. Left and downward, negative. Okay, then now final velocity means by the velocity at this final position over here. I don't think we know it, just know it arrives here, but it doesn't tell you arrive at what velocity, so we leave it blank. Next, the acceleration in the x dimension. Well, this is projectile motion. Projectile motion in the x dimension, it's constant velocity. This one is fixed, so we just write it in. And because we write it in, and we know acceleration is 0, therefore we know the initial and final should share the same velocity because it's a constant velocity. Okay, so this is x. Let's fill in for y as well. So y, we want to know what is the s displacement in the y direction. So this is the initial, this is the final. So if you want to do sy will be from, okay, this one is a bit challenging to draw. I need to find from this level to that level. This will be sy. But do we know it? Yes, we know it. It's 2.62 meter. Okay, our final position here is 2.62 meter. So we can write it in 2.62 meter. Okay, my apologies here. This I should dot it with respect to the point M, not the final position that I draw. Let me redo it, just in case it causes people to be confused. Okay, should be based on point M that we have here. Okay, so this is our sy, and yeah. Okay, so this is sy. Uy, we know that we want uy, we just resolve. So this is the opposite side. So resolve opposite side, you use sine. So you get the answer 15 sine 32 degree. Again, check whether it's pointing upwards or downwards. In this case, it's pointing upwards, so it's a positive 15 sine 32 degree. If it's pointing downward, then it's negative. Okay, Vy here will be the velocity, y component velocity at this point over here. Do we know it? No, we don't know because yeah, they didn't mention anything in the situation. Lastly, the y component of acceleration. This one is fixed. We always know it because due to gravity, you have a downward acceleration, therefore negative, and the value is 9.81. Okay, then lastly, do you know the time? How much time it takes to go from this initial position to that final position? No, but that is what you need to find. Okay, so once you have done until this part, right, you can proceed to the fourth step. Fourth step will be to determine the suitable equation. But here we have two components, right? You might not be sure what component should we do it. Should we do the x component or should we do the y component? This one, it really depends on the situation. But let's see. What we want to do here, what we want to determine here is t. Okay, and what information do we have? Here we have two information. And here we have three information. Okay, so just by seeing this, right, we know that it's most probably we are going to do it in the y component because y component has more information. Plus, if you see here, this acceleration is 0. So 0, right, you usually can make certain terms 0 and it makes things a bit complicated. So our intuition will tell us that you need to do it in the y components. And yes, indeed, it is using the y component. So you need S, U, A, and T inside the equation. And if you think about the 4 kinematics equation, you know that the equation that you should pick is S equals to UT plus half AT squared. Okay, we don't want V inside our equation because we don't have V and we don't want the answer of V for now. Okay, so this is the equation. Let me label this as question A because it's a bit confusing. Now let's just substitute. Okay, based on what we have in the table, Sy is 2.62, then you bring in 2.62. Uy is 15 sine 32 degree, then you put in the value exactly, time plus half AY is how much? Negative 9.81 t squared. Okay, so now you end up with a quadratic equation, and if you now you do it with your calculator, it's allowed to do using calculator, and you find your answer to be t equals to 1.16 second or 0.46 second. Okay, so means by these two answers here are possible candidates for the amount of time needed to travel from the initial position to point M. But which one is the answer? Well, you have to think about it. This equation says how much time do I need to achieve a displacement of 2.62. That is what the calculation is calculating. How much time it takes for me to go from the initial position to rise up by 2.62. Well, there are 2 points which your displacement is 2.62 if you think about it. Over here, when you are traveling, at this point over here, your height will also be 2.62. So your y component of displacement will also be 2.62. And of course, at point M over here, your displacement will also be 2.62. These 2 points over here has a displacement, y component displacement of 2.62 from the initial position over here. So I believe if you know that there's 2 points that you may get 2.62 meter, you know that one of them will be for one of the moment, another one will be for another moment. Make sense? Time starts from 0 over here, right? Then once it hits 2.62, once it hits this time, then it's 0.64. Then it continues its journey, reach the peak, then come back down, hit another 2.62. That's the second time. So from here, right, just by using our logic, we will know that this is not our answer because this is the point before the maximum height. We don't want the point before the maximum height. We want the point after the maximum height. So it must be a later time, not the earlier time. So what we can do is we can reject this one. We can say rejected. And we say it's rejected because object has passed the maximum height. Okay, so our answer will be t is equals to 1.16 second. Done. So that's it. So what does it mean? It means you take 1.16 seconds to travel from initial position until reach point M. Okay, let's look at the next question. Calculate the horizontal distance from point O. So technically, what are they asking for? They're asking for if you travel from the initial position to point M, what is the horizontal distance from the initial position to the final position? So for this case over here, if you follow up with step 2 initial and final position, we'll know that the initial and final position is the same as question A. It will still be the same initial and final position for question A and question B. So what does it mean? It means for question B, we can reuse the SUVAT that we have written down over at this side. So this thing here can be reused over here. Okay, because you are doing it with respect to the same initial and final position, so you can reuse it. So now if we look at the situation, we want to determine horizontal distance. Horizontal distance here is Sx. So it means let me use another pen. Okay, red pen. So right now what I want is Sx, what I have is U, and what I have is A, and you can have information here, the T here, you have obtained it just now, so you can use T as well. So if you want to build an equation, then you build an equation probably using S, U, A, and T. Of course, if you want to use S, U, V, and T is allowed as well. Okay, because you know the exact value, so you can do SUVT or you can do SUAT, but you cannot do SUVA. Okay, because as I said, if it's constant velocity, right, these 3 information you cannot assume as 3 information. You can only take 2 of them only, or else your equation will cancel. Okay, just take 2 of them. You take UV or you take VA or you take UA. Okay, you must put u inside. All the equation has u. So SUAT, okay? Cut it short, I use SUAT. Okay, so let me write down my work. So it'll be S equals to UT plus half AT square. Again, I think through my mind already. If I want SUAT, what equation should I pick? I should pick S equals to UT plus half AT square. If you pick SUVT, then you probably need S equals to half U plus VT. Okay, check which equation has the variables that you need. Okay, now you have determined your equation. Move on to step 5. Step 5 will be to do substitution. In substitution, Sx you don't know, so leave it blank. Then Ux is 15 cos 32 degree. Time is 1.16 second plus half 0, Ax is 0, t square is 1.16 square. So technically, because this one is 0, right, you already cross out the second part of the equation. So you are left with Sx equals to Ux times t. And if you calculate it, I believe you should get an answer of 14.76. Okay, so that's the horizontal distance from point O to point M. And yeah, that's basically what you can label here, 14.76 meter. Okay, so again, we go through the same 5 process. Visualize the situation first, then move on to the sub-question, determine the initial and final position for the sub-question, do the table, SUVAT table, determine the usable equation, then we substitute and obtain our answer. So this is example 1.